Okay. So remember, today we're taking a mastery check over transformations. So definitely pay attention. Okay. So on this first one, it says we've got describe the transformation. Okay, this is like one of the questions on your mastery check. Gonna say, hey, take this and describe it. Okay, that negative out front is always going to mean a reflection. Okay, the 3/4 means that we're gonna shrink because it's less than 1. The -7 means that we're going to move to the right 7. Okay, everybody always forgets that negative and positive, you got to flip the sign. That's the directions that it's moving in. Okay. Questions over that? Yep. Yes. Okay. Now, number 2, it says describe the transformations. So we've got negative. What does that mean? Reflection, right? We've got a 4 out front. Is that a stretch or a shrink? Stretch of 4. Okay. We got a -7. What does that mean? Right 7. And then -3, what does that mean? Down 3. I don't know if this will help you or not. This is how my brain works. I draw like kind of things like this. So positive, negative, negative, positive. So I know that if I look at an equation, it makes sense in my head. But again, that might mess you up. So. Okay. Yep. Positive where? Inside the parentheses, in front of the parentheses, then we wouldn't have a reflection. So if it was positive, there was no negative here, then it would just be no reflection. You wouldn't say anything about it. It would just be a stretch of 4, no reflection. Yeah. Okay. On the next one, this is like number 1 on your mastery check. Okay. They're going to give you a verbal description and they're going to say, hey, write the equation. Cool. So it says y equals x squared. Okay. So that's what we're starting with. So what I want you to write on your paper is y equals parentheses x and kind of leave some space. Now it says compressed by a factor of 0.4. So where are we going to put that 0.4? In the front. It says reflected. What are we going to do that? You're going to make it negative. It's translated right 7. So is that minus or plus? Ooh, -7. We got that little squared up there because that makes it quadratic. And then it's down 5 units. So -5. Okay, so when you read these, you just kind of work it along with what is being said. Okay? Yes.
Would it make a difference if we put the negative inside the x instead of 0.4?
Yes. Because that would be x squared, which would make that positive. So negative out front. Now, if it was written like this, with no parentheses, then that would be negative. It would be a reflection. That makes sense? Okay. Again, blank sheet of paper or wherever you can find space. We're just going to practice a couple. On the first one, if I had a shrink of 1/2, reflected, left 7, down 4, what would the equation be? Okay. So if I were writing this, I would say parentheses x, and that little squared up here. We have a shrink of 1/2, so that 1/2 is going to go out front. It's reflected, so it's going to be negative out front. Left 7, that means we're going to do +7 and -4. Did you get that? Okay. So here's another one. Stretch of 6 right 8 up 2. What would that equate? Okay, so on this one, we should have gotten 6 out front minus 8 squared up 2. Question? No. Shrink and stretch have nothing to do with the negative. Reflected means negative. If it's shrink, it's just less than 1. If it's stretch, it's more than 1. Yeah. Questions? Okay. There's one more question on your mastery check. And it looks like this. This one trips people up a little bit, so make sure you pay attention. If I said x squared plus 4 is the original, and I say I want you to move up 6, left 3, and reflect. Write that down, and then I'm going to show you how to do this one. Okay, so instead of starting from y equals x squared, which is our parent function, we're starting from this guy. Okay, so if we go up 6, we're going to say 4 plus 6. What is that going to give me? 10. So plus 10 is going to be on the outside. If we go left 3, that means that we're going to go x plus 3 squared. And if we reflect, we're going to make that negative. Okay, so instead of us starting at x squared, we're starting at this equation right here. Yeah? Yes.
So when we said down 6.
Uh-huh. Minus. Yeah. 2. Right. And that would be negative 2 out here. Exactly. Cool. Okay, let's try one. If I gave you what? Because that makes it quadratic. Yep. Because otherwise it's a linear function. So if I go down to right 8, what would that equation look like? Okay, so down 2, so 3 minus 2 is going to give us 1. So we're going to have a 1 on the outside. Right 8, it's going to be minus 8, and we're going to put that little squared. No, it's not going to be negative because it doesn't say anything about reflection. Cool. Yes.
Like instead of a negative,
I don't know what you mean. Like on the front, you just leave it. Negative is the only, like, if it's negative, it's gonna have a symbol. Otherwise, everything's positive. Yeah. Yep.
So on the first, it's like when we did up 6.
Yeah.
Then we added 6 on 4, and then we had plus 10.
Mhm.
This was down to instead. Then we negative. So because we only got
3 minus 2. So if I have 3, and then I went down 2, it'd be at 1. Like here's our graph.
Oh, it's just like what this
It's moving from 3 down to 1. Yeah.
I was just saying we go down. So I just leave it at 1, but
Mm-mm.
this goes down.
Mm-hmm. Okay. We need another one? Yep. Okay, one more. All right, if I had x squared plus 10, and I went down, actually, let's do something crazy. Down 14, and to the right 6, reflected. Take a second. So we've got down 14. So from 10 minus 14, that's going to be negative 4 on the outside. Right 6 is going to be minus 6. And reflected is going to have that negative out front. Oh. So this right here makes that quadratic. This right here makes that quadratic. If we just wrote x plus 10, we would have a straight line. The squared is what makes it go like this. Yeah. Questions on that? Okay, so one question is going to be like this. One question is going to be like this, where they give you a description and you write it. Okay, I need you to pay attention to whether they're talking about the parent function or if they're giving you some other function to compare it to. Okay, and then one is going to be like this, where they give you the equation and they say, hey, tell me the transformation. Any questions? Yes.
More examples on the equation, and we have to describe the transformation.
So like from this to something else. Okay, give me one second. Oh. Okay, if I have this, describe the transformation. Right, so the first thing that you want to mention is that it's reflected. Next thing you want to mention is that it's a stretch. The +6 inside the parentheses, that means that it's going to move left 6. And then the +14 on the outside is going to mean up 14. No, y'all can list this out whatever order. It just makes it easier if you have some type of pattern. Yeah, you can work it backwards, forwards, whatever. Good? Yep. Okay, so x + 6, this is going to be left. X - 6 would be right. It's like opposite of what we think. I just work here. That's the one that's the part that's tricky. I am going to leave what's over there on the board, that purple stuff. That's going to be left on the board. Okay. Now, I don't know how much help it is, but I'm going to leave that there. Yep. The stretch, the number that's out front. If it's bigger than 1, it's a stretch. Less than 1, it's a shrink. Define the zeros, the x-intercept, the root, right? Okay, so what that means is we're going to take this factored form, and each part, we're going to set it equal to 0 and then solve. So we got x - 4 and x + 1. We're going to set both of those equal to 0. And then we're going to solve. So we're going to get x by itself. We did all that practice on solving the other day. So we're going to add 4, and then we're going to subtract 1. So this is going to be 4, 0 and -1, 0. Questions on that? Okay. Now, axis of symmetry, that's the middle number. That's a number that's in between these two numbers. So from -1 to 4, what's my middle number? What's in between? What's in between? I'm sorry, 1.5, right? Okay, here's where a majority of you messed up on 4.2. You got the axis of symmetry, you did fabulous. But then when you came to the vertex, you only have the x value for the vertex. So in order to get the y, you got to plug that guy back into the original equation. So somebody in their calculator, type this junk in. Type that in your calculator. Yeah. I didn't plug it in, so I don't know. Okay, is this a minimum or a maximum? And how do we know? Well, isn't this equation positive? Like there's no negative chilling out front, right? So that means that it's going to be facing upwards. Does that have a minimum or a max? Minimum. So this guy's going to be a minimum. Now, if you don't want to do all of that math, on the next one, what I want you to do is take this guy, graph him in Desmos, and then tell me all this information. Okay, so take a second, try that one. All right, let's talk. So you should have gotten an axis of symmetry that's x = 3. You should have gotten a vertex that was 3, 0. You should have gotten a minimum because it's positive. And your y-intercept is 0,9. Okay. Now, eventually I'll teach you how to do this actually in your head, but we're not there yet. Okay. Cool. Okay. On the next one, we're talking about a rocket. Okay, before we even like start doing any craziness, we got some rocket. It's chilling right here. This is my awesome rocket. It takes off and then comes down here. Cool. This guy's maximum. Gucci. All right, let's read our statements and select all that are true. So the rocket is launched from a height less than 20 feet above the ground. Where is this guy starting from? 0. Is that 20 feet? Less than 20 feet above the ground. Yes, so that guy's true. It's a really weird way of saying it, but yes, that's true. The rocket is launched from about 20 feet above the ground. Is he at 20 feet? Right here? No. Wrongo. The rocket reaches its maximum height after about 3 seconds. So at about 3 seconds, does it reach its maximum height? Yeah. Does it reach its maximum height after 160 seconds? No. The maximum height of the rocket is 160. Is that a true statement? Yes. The rocket lands on the ground at 6 seconds. Is that true? No. It's about 6 seconds, right? Or after 6 seconds. And then the line is symmetric about the line x equals 4. Is that true? Because where's our axis of symmetry? 3. Okay. Now, down here, it says explain why it is incorrect. All of those things that I was saying out loud for the justification, that's what you would be writing down. Okay. On your test, there's a question very similar to this. And you have to write the reason why. Okay. You can't just say yes or no. You gotta be faster. All right. The vertex, we got 5, -4, right? Is that a maximum or a minimum? So the lowest or highest point? Lowest, so that's a minimum. Okay. Now, what does it represent in context? All right, so we got this little bird. Don't laugh at my bird picture. Yes, tweet, tweet. All right, and then we got this little fish down here. Yeah, look at him. Okay. And this guy is like on a tree branch. This is my awesome tree that has some random branch out here. Look at that. So good. Okay, so he's starting at 21. He's swooping down. He's going into the water. Here's my water. Okay. So what does the vertex represent? What's happening here? He's not going. He's not going in the ground. He's going in the water, right? Right here, where it says the fish in the water. So what happened? He's diving down and grabbing what? So the vertex is where he grabs the fish. Okay. Now domain. We're looking from left to right. So from the tree, how far does he go? From the the tree, how far does he go? Okay, so we go from 0 to 9. That's how wide out it is, right? And then what is the range? How low does it go? Well, what's the lowest y value? -4, and how high does he start? 21. So -4 to 21. Now, what does the domain represent in context? Well, the domain represents how far from the tree. The range represents from him catching the fish to top of tree branch. Okay, what's the y-intercept? And what does that represent in context?
The bird sitting on the tree branch.
Birds chilling in the tree. Okay. And what are the x-intercepts? Where does it cross the x-axis? 3, 0, and 7, 0, right? And on the next page, it asks, what does that mean in context? So what does 3, 0, and 7, 0 represent? Enters and exits the water. Cool. Okay. I think average rate of change is silly to ask, but we get asked this. So from 0 to 2, you can use this fancy formula that you learned back in 6th grade. Whoopee, great, fabulous. Or when you look at the graph, we're going from 0 to 2. So how far down do we go? How many units do we go down? We're going to go down 8, and then we go to the right 2, right? So what is -8 divided by 2? -4. If you would have done this the like formula way, you get the same thing. Okay, where 0 is x1, 2 is x2, your y values are 5 and -3. When you plug it into the equation, you get -3 minus 5 over 2 minus 0. You get the exact same thing. Okay, you can do it the formula way, you can do it the graph way. Graph way is probably easier to remember. Okay. Okay. So on this one, it's saying let f of x equal this, g of x be this. Check all that are true. So from f to g, has it reflected across the x-axis? Well, look at f. Is it a positive value? Yes, it's positive. Look at g. Is it negative? Yes. So did it reflect? Yeah. So this is like start to finish kind of question. Now the graphs of f of x and g of x, are they both facing upward? No, because g has a negative, right? Okay, this is the one that trips everybody up. So from -4 and 3. So remember, when we graph these guys, this would be to the right 4. This one would be to the left 3. So from this guy to this guy, do we move 7 units to the right? To the right? No, it would be to the left, right? So this guy's wrong. On this one, if we went from 2 to -15, did we go down 17 units? Yeah. So from here to here, did we shrink by a factor of -5 or did we stretch? Okay, so wrong, stretch. Very similar to the distinguished question. All right, so you see these points. What is a graph that can pass through all 3 of these points? Well, let's just connect the dots really quick. I could do a graph that looks like that, right? That means that this guy would be the vertex. So what is this point? What is this location? -2, 1? Yeah. Okay, so we're going to write out an equation. So -2 would make this +2 and then +1. It would be facing downwards. So we got a negative out front. What we're going to do now is we're going to graph it and check and make sure that it passed through all of these 2 points. Okay, so when we graph it, does it pass through 0, -3 and 3, -3, 0? Yes. So then that could be our graph. Now, what are the transformations on this one? Well, it went reflected. It went to the left 2, and then it went up 1.